In this video here, we're going to talk about how to find the inverse of a function, right? Given a function like this, f of x equals 3x minus 2, how can I figure out what the inverse of that function is, right? So that's what we'll be talking about here. Right now, if you haven't seen the video that I did on the definition of an inverse function and the explanation of what an inverse function actually is, you might want to check that out, because if you understand what an inverse function does, what we do to find the inverse then makes a lot more sense, right? Because you see that connection between what an inverse is and then these steps that we use to find the inverse function. And if you watch that video, you might recall that inverse function, or what an inverse function does, is it switches the domain and the range of the original function, or switches the x and y values, or the inputs and the outputs, right? So it switches all those things. It basically undoes what the original function does, or does the original function backwards. It's a couple different ways to think about the inverse function, right? So if you recall that inverse functions switch the inputs and outputs, they switch the x's and y's. Well, the key step when we are finding the inverse of a function is to interchange the x and y values. We switch all the x's and y's, literally change every x to a y, change every y to an x. Right? So if you understand what an inverse function does, it makes it a lot easier to remember that when you find an inverse function, that's what you need to do. All right, so the basic steps for finding the inverse of a function, like the algebraic method that we use to figure out what the inverse is. First thing, write y equals f of x. Right? So if your function is given to you in terms of f of x equals 3x minus 2, what we want to do first is write that instead of f of x, we just want to use y, right? So use y instead of f of x. That just makes it more convenient to do the steps that come up later on. Rather than using f of x every step of the way, we just use one single letter, a y. It makes it more convenient for us, right? So that's the first thing. Instead of the f of x there, just put a y in its place, right? Step number two, the key step when you're doing one of these, let me put a star next to that, because that's the key thing. We interchange the x and the y. Right, again, the definition of an inverse function is it switches the input and output values from the original. It switches the x and the y coordinates. Right? So if we want to find the inverse, we do exactly that. We switch all the x's and the y's. Right? Once we do that, then we solve for y. Right? So whatever equation we end up with when we switch all the x's and y's, we then have to solve that equation for y, and the result that we get is y equals f inverse of x. Right? So when we solve for y, after we switch x's and y's, whatever we get is the inverse of the original function that we started with. Right? So it's not real hard to do. The key thing again is understanding the steps. You interchange the x and the y, you then have to solve for y. Now, depending on what book you use and who wrote that book, sometimes they give this to you in a different order. Sometimes it'll say, first solve the equation for x and then switch the x and the y. That works just the same. So if somebody's telling you something different from this, or you read something different from it, you can go either way with it and it should come out to the same result. I like to change the x and the y first and then solve for y, because I'm just more used to solving equations, rewriting equations in terms of y equals instead of writing equations in terms of x equals, a bunch of stuff that has y in it. So for me, it's easier to do it this way. But again, if you see it, these second and third steps kind of switched around, that's okay. That'll work too. So whichever way you prefer is okay to do. All right, so let's actually go ahead and do this. Find the inverse of f of x equals 3x minus 2. Right, so this one is a pretty simple example of finding an inverse, just to kind of get our feet wet with it and see how it works. Then I'll do probably another video where I do some more difficult examples. And the only thing that makes this difficult, once you understand the basic steps of how to do this, the only thing that makes it more difficult is what this function looks like. Or if that function includes maybe some higher powers of x, or more than one x in the equation, or maybe there's a fraction involved or something like that, that could possibly make it more difficult. But you're always following the same basic steps. Right? It's just when you get more difficult equations, sometimes the algebraic stuff gets a little more complicated when you're doing this last part of solving for the y. All right, but anyway, let's get into this. Find the inverse of f of x equals 3x minus 2. So step number one, instead of f of x, I want to write this as y equals 3x minus 2. Okay, it's just going to be more convenient to do that rather than to carry that f of x through every single step of the problem. That's kind of a pain in the neck to do that. All right, so I write it as y equals 3x minus 2. Step number two, the key step, interchange the x and the y. So everywhere I see the letter y, I write an x, and everywhere I see an x, I write the letter y. All right, and if I had more than one x in the equation, I would put a y for every single one of those x's that I have. Right, so when I switch the x and the y, I get x equals 3y minus 2. Right, everything else stays the same. The 3 is here, the minus 2 is there. Just the x and the y, I literally switch out each letter and change their positions. All right, so I get x equals 3y minus 2, and now the last step, solve for y, right? So now I have to do the algebraic stuff to get this y here by itself, right? I have to isolate that y. And it's just like if you're solving a regular equation. So since I have 3y minus 2, first thing I have to do is add that 2 to both sides, which is going to give me x plus 2 equals 3y. All right, the plus 2 and the minus 2 cancel each other out over there, so I get x plus 2 equals 3y. And then, since I have 3 times y, what I need to do is divide both sides by 3. Right, so let me bring this up here. So I end up with x plus 2 over 3. Let me write that so you all can actually read it. I end up with x plus 2 over 3 equals y. All right? And now I have solved for y, right? I got that y by itself on one side of the equation, and it doesn't matter which side of the equation you leave the y on. You can leave it on the right, you can bring it to the left if it's more convenient to do that. So we get that, and now my result is y equals f inverse of x, right? So the last thing I want to do now is write this in that inverse function notation, right? Just like up here, I changed the f of x to a y. After I switch the x and y and do all this stuff, I now want to change the y into the f inverse, right? So I would say f inverse of x equals x plus 2 all divided by 3. Right? That's my inverse of f of x equals 3x minus 2. Right? So that's how we find the inverse of a function. It's really not too bad, especially with a simple linear function like this. Like I said, sometimes it gets more complicated, and I'm going to do another video where I do a couple of examples of more complicated functions and doing the algebraic steps to solve those. So if you're looking to do more complicated problems, check out the other video that I'm going to do where I take you through some of those more complicated steps. But anytime you're finding the inverse, you follow the same basic thing, right? You switch the f of x to a y, you change the x's and the y's, switch their positions, every y becomes an x, every x becomes a y, and then you solve for y, right? And that's where sometimes it gets more difficult. In this case, it was pretty easy. All I had to do was add 2 and then divide by 3. It was 2 steps, and I had the y by itself. If you have more than one y here, or if you have things raised to powers or fractions, sometimes it gets more complicated. But then it's just, like I said, doing whatever algebra you need to do to get the y by itself, and then that y is your f inverse of x, right? And notice the relationship between the original function and the inverse, right? The original function, if I plug a number in for x, the first thing I would do to that is multiply it by 3, and then I would subtract 2, right? Multiply by 3, then subtract 2. Well, the inverse function does everything exactly the opposite. Whatever number I plug in, first I add 2, right? So here we were subtracting 2 last. Now I'm adding 2 first, and then I'm dividing by 3. Right, here we were first multiplying by 3. Here the last thing we do is actually divide by 3. Right, so when you're doing a function and its inverse, everything is the opposite. The order that you do things, and then also the operations. Right, instead of a minus 2, there's a plus 2. Instead of a multiplying by 3, there's a dividing by 3. All right, so if you do a lot of these problems where you find the inverses of the functions and you start to see how they relate to each other, you might get to a point where you can look and say, oh, 3x minus 2, let's see, the inverse of that is going to be x plus 2 divided by 3. Right, because they do always have that consistent pattern to them as far as how they relate to each other. Although it gets a little trickier sometimes if you have rational functions. Sometimes it's not as easy to see that pattern or that relationship. But for basic linear functions like this, you can kind of just tell what it's going to look like. It's going to be a plus 2 and then a divided by 3. All right, so that's the basic steps of finding an inverse function. One fairly simple example. And like I said, check out the other video that I'm going to do where I do some more complicated examples and work through how to find the inverses of those functions. It's going to be the same 3 steps, just more difficult algebra as we're solving it.